Okay, we have another interesting integral from MIT 2022 quarterfinals, round one, problem one. We have the integral from 1 to 2022, the fractional part of x over x dx. Okay, to get started, of course, what we want to deal with is the fractional part right here. So for that, maybe the best way to start with is with an example. If you've got something like, say, 2.31 and you want the fractional part of that, well, that's just going to be 0.31. If you had an integer and you wanted the fractional part of just like, say, 5, it's just going to be 0. So pretty straightforward. With whatever the value is, you want just the fraction part. Now, I think where it gets a little more confusing is if you had something like minus 3.8. I don't know that there's one standard way to handle this, because the question is this going to be like 0.2? Do you take it from do you take the base as minus 4 and then it's 0.2, or do you just take the fraction part here and get 0.8? I don't really know the answer to that. Maybe I'll look into that more later. I think it's just kind of a matter of the definition, but I think different people do it different ways. So anyway, for this one though, what we're going to do is we're going to consider x greater than 0, and that's going to be easy for us to do because our integral is going from 1 to 2022 anyway, so that's no problem. And so then the question is, for the fraction part, how are we going to handle it inside of an integral? Well, what we can do is use this definition for the fraction part. If we've got the fraction part of x, we can write this as x minus the floor function of x. And this holds again for x greater than 0. So this is pretty nice because we know how to deal with integrating the floor function. I've done that in a bunch of other videos. So like coming back to our fraction part of 2.31, breaking it up this way, this would be the same thing as 2.31 minus, the floor is going to round us down, so the floor would be 2. Doing this, we get the same thing, 0.31. So what I want to do is let's just take this thing right here and plug it into our integral, but with the minus sign, I can actually break this up into two integrals. So for the first one, we're integrating from 1 to 2022. We'll have x over x, so we're just integrating 1 in this first one. And then for the second one, now we'll have the floor function in the numerator, so it's going to be just floor of x over x dx. Well, for this integral here, now that we have the floor function, I can do this the way I usually do it, which is break it up so that we have our bounds just separated by 1, like going 1 to 2, 2 to 3, 3 to 4. That way, this is going to just become a constant value. So like, let's see how it works. If we go from 1 to 2, the floor is going to round us down to this lower bound. So we're going to end up with just 1 over x. And then the next one, going 2 to 3, same kind of thing. It's going to round us down to this bound here because all of our x values are between 2 and 3. So it's going to become 2 over x. But what I really want to do for this is generalize it, because I don't want to write out 2,000 something integrals. In order to do this, let's do it as, we'll say, we're going to integrate from n to n plus 1, so we're still just separated. N's an integer, we're just separated by 1. The numerator is going to become this n value over x dx. But with this being a constant, I can rewrite it and bring the constant out front, and we can write it as we can write it this way, from n to n plus 1 of just dx over x. So using this, let's get back to our problem here. Of course, I can integrate 1. So when we do that, we just get x evaluated from 1 to 2022. Let's just, I'll write it out. So we'll write it here. We'll have x from 1 to 2022. And then here, okay, we're going to have this, but it's going to be not just one integral. It's going to be this sum. So we can write this in sum notation as a sum from 1 to, not 2022, because our bound is based on the lower bound, so it's actually going to go to 2021. And then we can kind of just plug this in here. Just notice again for this 2021 value, if you plug this in here, the lower bound's 2021, the upper bound's 2022, and so then we're matching with what we have over here. Okay, so let me make a little space so we can finish this thing off, or get close to finishing it off, I guess. So now this part's easy. We're just plugging in 2022 minus 1, which is just going to be 2021 here, minus this sum, but we can actually just integrate this. So we'll bring the sum out front. And then for this integral, this is just going to be natural log. I'll drop the absolute value because the n values are always positive, so we don't need absolute value on it. And then it's going to be just natural log x from n to n plus 1. And when I do this, I think let's bring the n into the exponent here. I think that's going to help with it. So then we'll just evaluate it. So first plugging in n plus 1, we get natural log n plus 1 to the n minus evaluated n, and we get natural log n to the n. But then with log properties, we're subtracting, so I can bring this together and divide by n over n here and get rid of this. Since we have the same exponent, I could kind of pull it all together, but I don't want to. I think it's going to help me with the simplification to leave it. So what's going to happen, I think what I'm going to do, let's start plugging in terms on this thing. We've got the 2021 out front. So first we plug in 1, and we're going to have natural log 2 to the 1, not simplifying anything, 1 to the 1. Then the next one is going to be natural log 3 to the 2 over 2 to the 2. Then when n is 3, we get natural log of 4 to the 3 over 3 to the 3. I think you can see the pattern, so this is going to go on and on like this forever. And actually, I shouldn't say forever because it does come to an end at 2021. So let's just do the last term, I think. So at the last term, we get natural log of 2022 here to the 2021, and then 2021, 2021. But then with log properties, we're adding all this stuff so we can bring this all together in a giant product and multiply all this stuff together, 2022 terms or 2021 terms, whatever it is. But then now bringing it all together, the nice thing is all the cancellation we're gonna get. So like when we have, that's just the 1, we're not worried about that. We can cancel 2 with just one of these. The same thing with 3 squared. We cancel that out. We cancel off 2 of these, and we're left with just 3. So we have like 1, 2, 3. Same thing's going to happen here. This is going to cancel and leave a 4 here for this term that we can't see. This one, there's going to be another 2020 over here that's going to cancel out this exponent. So we got 1, 2, 3, 4, all the way to 2020. Then this one here, it's going to cancel this with all of this. This thing, nothing's canceling this. So when we simplify it, let's see what we have. We still have this 2021 here minus natural log. Then we're left with everything in the numerator canceled out except for this one term. So it's going to be 2022 to the 2021. And then in the denominator, look what we have. 1, 2, 3, 4, all the way to 2021. You reverse that, and what that is 2021 factorial. So for my final solution of this, we just get 2021 minus natural log 2022 to the 2021 over 2021 factorial, and that's it. Okay, so really nice use of the year, and I really like the cancellation in the end, so that was a good one. Thanks everyone for watching. Have a good day.